Okay, so the trig. What we're doing right now is I'm looking at problems 22 through 25 first, and we got the trigonometry piece that's going to be here. Here is the thing that I'm going to say, mostly because I want to save some time to get through some different things. Problems 22, 23, and 24, and really most of 25, but I think we can get to, I'm going to start with that one, are really things that I did the videos of before when we looked at the stuff on the unit circle. And so email me if you don't have those videos and I can send them back to you. But I think you can just look at those because it says the same thing and I don't want to repeat myself with something where I can get to newer stuff. However, getting to 25 and then moving on to the end to the stuff on the next page, I think we have some things that we could feasibly work on. So for instance, I want to start with 25. We're going to go with C because that's something that's a little bit different. And they give you that the 3 tangent of theta minus, I believe that says 2, let me make that a little bit bigger, is equal to 1. And they want to know where are all the values between 0 and 360 for theta that will make that work. All right, dude, all we're really doing here is just working at finding some numbers and seeing what's going to happen. We are not as familiar with the tangent values, but that's not that big of a deal. Essentially what we're going to have to do is this. I'm going to just move some stuff over, and we're going to see what we're going to get. In the case of this, we want to isolate whatever we have as our trig value. And so the value that I want to isolate in the case of this one is I want to isolate tangent. So I'm going to add 2 to the other side first. We get 3 tangent of theta is equal to 3. I'll divide by the 3, so we're going to say the tangent of theta is equal to 1. Now, what this means as we look at something like this is, I remember we talked about before that the tangent is the same as the sine divided by the cosine. So what this really means is that the sine over the cosine is equal to 1. We're looking for all the places on the unit circle. I'll multiply this cosine on the other side where the sine of theta is equal to the cosine of theta. Now, I can tell you, because I know that you're looking at the unit circle that you just created for yourself, because that's the way that you work, is if these things are the same, that means the triangle would have to have the same value. So these are going to be at all of our 45-degree reference angles all the way around the circle, because those are the places where we have the little triangle would be 45, 45. This is a 1, and these would both be root 2 over 2. So we'd have the two values, both the cosine value and the sine value, the same. But we have to remember that because we're looking at where they're going to be actually equal to each other, the positives and the negatives are things that we're going to be looking for. So the only places on the unit circle where these two things are the same, including positives and negatives, are at 45 degrees because they're both positive, and at 225 degrees because in the third quadrant they're both negative. So those are the two values that you could find to make something like this work. Really, the only other one of these that seems strange to me is F, but I want you to do it in exactly the same way that we just did this. So that I think what's going to end up happening as we do this, you're going to get square root of 3. It's not a hard thing to do. Just use your values, do a sine or a cosine, and see what you can actually find. Now, as I move to the next page, what we're dealing with here is the graphs of the trig functions. And it's also something that we have videos of, that you can look back at the general basis of these different things. But I love the questions we're starting with. By the way, this is my phone so that we can look at the actual values that you sent to me. What I want to look at as I'm seeing this is the fact that it asks you some questions about vertical shifts and amplitudes and horizontal shifts and the periods and what's the equation of the graph that you chose above something like this. What I think is important for us to think about as we're doing sine and cosine graphs is that you remember what shifts with what. And so just very quickly, what I'm going to do is just do a really quick overview of this one more time so that you can have a chance to see it. And essentially what you're going to be looking at is you're looking at a parent function, y is equal to sine x, or y is equal to cosine x. Neither of these things really change very much. It's just a matter of where they start. Again, if we're talking about parent functions, I'm just going to do really quick for both of these. 2 pi is our period, because that's how long it's going to take to get through a whole thing. Sine is the one that starts at 0. Our amplitude is 1. So what this essentially is going to mean, it's the same for both of these. It's just that the cosine starts at 1. And so what I've always done with this is just know all my points. This is pi over 4, excuse me, pi over 2, 3 pi over 2. And so this one's the one that goes like this. These have the same values. It's just that this one goes through like that. Now, essentially, here's what ends up happening. When we're shifting this, I'm going to pick a specific one. I'll pick sine. You've got a lot of things that you can do to mess with the graph. So you could put an A in front of the sine. That changes your amplitude, or how tall these things are. I'm going to leave a little space here. You can do, now I don't remember the number that they use, but I'm just going to say x minus h because that's what we've done. You could do a horizontal shift, where if it's a minus something, you could be moving it along the axis this way. Normally it's like a pi over 2 or a pi over 4. You could be doing a vertical shift, which would be something we have here, moving it up and down. That would be our k. And then you've got something here, I believe that they used b, that changes the period of the function. What you do with when you multiply this number that's here, this number for the period indicates how many times in 2 pi we go through a period. So essentially, if we want to find out the period, we can take 2 pi divided by whatever that number is, b, and it's going to tell you what that period is. And so in the case of something like this, when it asks you the period, you've got to sort of look and figure out how many times I've gone through during the 2 pi, and we can go through that. Now, it is asking you the equation in this first problem, number 26. What's the equation with the horizontal shift you chose in the graph above, and see what's going to be happening. And you can do all of that stuff. But really, you're just counting how many times through a cycle have you gone in a 2 pi period to make that happen. And then that's an indicator of what the period is. However long it takes here, that's 1 period. So this one, the parent function is 2 pi. I think that's enough information to get you started on this trig stuff. This is one that I'm going to expect to get some questions, but I do want you to look back and see what you have going on in the other videos and say, okay, I looked at the other videos, I looked at what you just said here about the period and what's going to be happening, and I want to have some questions answered about this, this, and this, and then we can go through what those are. But I want to give you the practice that they have here because I think you could figure it out. Because, dude, you're smart. Okay, talk to you later.